Hello, sixth grade. Today you're going to work on the study guide for Module 3, Rational Numbers. So you have a choice in how you do this. You can do the assignments, the 2 pages, and then come back to the video and check your answers. Or if you would prefer to do the problems along with me, you can do that also. It just depends on your preference and maybe the best way that you learn. So if you want to stop and pause and do the work first, that would be fine. And if you want to do it with me, that would be fine also. So we're doing page 65 and 66. And let's get going. Okay, first question says, 5 friends divide 3 bags of apples equally between them. Write the division represented in this situation as a fraction. So you have to think about what is being shared by how many. All right, so what is being shared is 3 bags of apples by 5 friends. 3/5 is how much of a bag each friend will get. Okay. The second one is the instructions say to write each rational number in the form of a divided by b, where a and b are integers. We talked about those instructions the other day, and that really we just want to write it in fraction form. So 5 and 1/6 right now is a mixed number. It contains a whole quantity and a fraction. So what we want to do is just represent that as a fraction. So 5, so our part size is 6, so we know it's going to be 6. And so if you think about this, 1/6 is a single 6, but this 5 we have to represent as 6. And 6, 6 make 1, so 5 would be represented by 36, plus 1 more makes 31/6. Same idea on number 3, -12. Although this is an integer, it can be represented as a fraction by placing it over 1, dividing by 1. Or you could also have said -24 divided by 2. It doesn't have to be in its simplest form, but that is definitely a fraction form of -12. Okay. The next section says determine if each number is a whole number, integer, or rational number, and include all sets to which it belongs. So let's just do a quick reminder. We said whole number is a W, integer is a Z, and rational number is an R. And so we want to include every set these numbers belong to. -12, if you remember, we have whole numbers here, and then integers, and then rational numbers. Okay, -12 is not a whole number, but it is an integer. And because it's an integer, it's also a rational number because all integers sit inside that rational oval. 7/8 is a fraction, but it cannot be written as a whole number or an integer, so it's only a rational number. Okay, the next section says to graph these quantities on the number line. So if you look at the number line, they are whole quantities. So -3 is pretty easy to spot. +3 is easy to spot. But we're going to have to estimate on the 2 fractional amounts. So 1 3/4, we know it's greater than 1 and less than 2. 3/4 is more than half, so it's going to be about that. And then -5/10 is -1/2. And so we would go right about there. It's greater than -1, but less than 0. All right, find the opposites of 1/3 and -7/12. Well, the opposite of 1/3 would be -1/3. And the opposite of -7/12 would be +7/12. And now we want absolute values of 2 rational numbers. And if you remember, absolute value is its distance from 0. So 9 8/10 would be 9 8/10. That's how far it is from 0. -10/3, it would be a +10/3 because distance or absolute value is always a positive value. Okay. Now, over the last week, the daily temperatures in degrees Fahrenheit have been -4. 6.2, 18.5, -5.9, or 5 9/10, 21, -1/4, and 1 7/500. List these in order from greatest to least. Greatest to least. Reading really important. Okay, I'm gonna say 21's probably the greatest. 18.5 would be less than that. So we're going, looking at just the positive quantities first in declining order. 1.75. Okay, now we have three. I'm going to highlight them so I can see them. 3 negative quantities, -4, -5 9/10, and -1/4. And remember that when we're going from right to left on a number line, you have to think about it being opposite of what it would be if it were positive. So the greatest of these negative quantities would be -1/4 because it's closer to 0. And then we would go to -4 and then -5 9/10, which is the opposite of what would happen if they were positive values. Okay, going greatest to least. Okay, so then the next question is, how can you order rational numbers from least to greatest? Well, placing them on a number line is one way. And also, if you remember, we talked about the idea of putting them all into decimal form. So rational numbers, least to greatest, I would say convert to decimals and place on a number line. Place meaning graph. It's a better word. Graph them on a number line. Okay, on the next page, we have Ms. Fortes asked her class to place sets of rational numbers in order, and we're supposed to indicate by yes or no whether they are done correctly, least to greatest. So, like I said on that last question, if they were all in decimal form, or they could also be in fraction form, it would be easier to say. We're doing least to greatest though, and I can see on A that there's a whole number between those quantities, and so that can't be least to greatest, right? 4/10 is not greater than 2, so that would be a no. So let's just look at B. Does it make sense? Well, if you have your number line that we made the other day, that would be helpful. Why don't you grab it? Okay, does this look familiar? I hope so. So if we look at B, -1/3, we can see -1/3. Ooh, we didn't put thirds. But if we wanted to make 1/3 a decimal, let me just add this to this list right here. 1/3 as a decimal is called a repeating decimal, because 3 is not a factor of 100, right? So I can't use the same method that we used on 1/4 and 3/4. So I would need to do the division. And so 1 divided by 3 means we have to put a decimal and a 0 here. What's going to happen is 3 will go into 10 3 times. And we are going to keep doing the same division over and over in this division problem. This is called a repeating decimal. So we usually say it's around 33/100ths, but it's not exact. 1/3 is an exact fraction, but its decimal equivalent is approximate because it's a rounded value. So anyhow, 1/3 would then, or 33/100ths would be, this is a negative, right? So it would be in between 4/10 and 3/10, but it would be closer to 3/10. So it's about right there. And then 25/100ths, we already said, is right here. So those two are in the right order. 2/10 is going to be over here, greater than 0. And then 1 is going to be way over here. So it appears that those are in order from least to greatest. So we can say yes on part B. And then if you look at C, we have -1/2, which we know -5/10 is down here. Then we have the absolute value of -1, which is 1, which goes way on the other side of the number line. And then 1 5/10 and 5. So this was also correct. Now the trick on that one is converting that absolute value of -1 to +1. That's what it's asking us to do. Okay. All right, on this next section, true or false? The opposite of a rational number is always negative. Well, what if that rational number is already negative? The opposite of a negative is not negative, so that would be false. The opposite of a rational number is always the number itself. Well, does that make sense? So if you say the opposite of the opposite, so we had -1. The opposite of -1 is 1, and the opposite of that is -1. So this is true. Funny wording, huh? The absolute value of a number is sometimes equal to the number itself. Well, that is true. If that number is positive, then its absolute value is also going to be the same. All right, on number 3, this question is really more related to what we were doing in Module 2 with the distributive property. So it says, Kaya rewrote the sum 96 plus 12 as 12 times the quantity of 8 plus 1. And the way she did that is she factored out the greatest common factor of 12. So 96 divided by 12 is 8. And 12 divided by 12 is 1. So she's changing it to 12 times 9 as the product that goes with 96 plus 12 as a sum. So that is true. She used the same method to rewrite 95 plus 15 as 5 times the quantity of 19 plus 3. And again, this is 5 is the greatest common factor, and they divided each of those add-ins by that 5. Now, that is called the distributive property. Okay. Distributive property was used in the first 2 problems. Okay. So now she wants to do the same thing with 38 plus 11. Okay. And the question is, can she? Can she do that? Well, 38 plus 11, the first thing you have to do is find the greatest common factor. And in this case, they're both, well, 11 is a prime number. 38 has factors of 1 and 38, 2 and something, 2 and 19, and that is it. So if 11 only has factors of 1 and 11, that means 1 is the greatest common factor. So really, you can't do it on this problem because the greatest common factor is 1. If you did, it would look like this, which is kind of silly because it's the same thing. So cannot be done here because the greatest common factor is equal to 1. Okay, final problem. The temperature at which water freezes is 0 degrees Celsius, but water with salt has a lower freezing temperature. Liz measured the temperature of several samples of water with salt. Explain how Liz can use a number line to tell which sample is coldest and which is warmest. Which sample's temperature is closest to the freezing temperature for water. So we can use a number line, right? Let's actually do it. Let's put this on a number line. So we know we're looking for the closest number to 0. And what do we have? We have, I'm just going to put 1 here and -1 here so that they're somewhat evenly spaced apart. 1 2/10 would be greater than 1, so it's maybe about here. -1 1/10 would be less than -1. -1/10 would just be a little bit less than 0. And 5/10 would be halfway between 0 and 1. So it appears that C is the closest to the freezing temperature. But it also tells us that because we've placed them on a number line and we can see that the coldest would be -1 1/10, which is B, and the warmest would be 1 2/10, which is A. But it is point C that is closest to 0. Okay. So you would just want to use some words to describe that, but using a number line is really the key on making that work. Okay. That's it. Talk to you later.